Hello dear students. So today we have another session of Brainiacs doubt clearance. So we have a new question in front of you. I will read the question. Please try to understand. The question here is 1 gram of magnesium is burned with 0.56 gram oxygen in a closed vessel. Which reactant is left in excess and how much? Okay, so I will tell the summary. The summary is you have a reaction where magnesium is burned with oxygen. So what is the expected reaction here? Okay, so we'll try to first write the reaction. Okay, so you have magnesium, correct? It is burned in presence of oxygen O2. So you will get, we know the fundamental reaction is magnesium oxide, correct? So if I am going to balance this reaction, you know that I will put it here too because two oxygen atoms are there. So here I need to keep 2, correct? So can you tell me now the stoichiometric ratio of this reaction? So I can write the stoichiometric ratio is equal to, we know that stoichiometric ratio is usually written for a balanced chemical equation. So the coefficient of each reactant is considered as the stoichiometric ratio. So here the stoichiometric ratio will be 2:1:2. Correct. Okay. Now, what is given to you? This is stoichiometric ratio. Now, given to you is, we will write that separately, given. So given to you is, there is magnesium is there, one of the reactant. So how much is given to you? Magnesium. It is given in the form of mass and that is 1 gram. Correct. Now the other thing is oxygen. O2 molecule. It is also given in terms of mass, that is 0.56 gram. Correct. Now we usually, whether mass is given or anything, we usually convert this into number of moles. So how can you convert 1 gram to number of moles here? You need to do the given mass by molecular, by, if it is atom we will say atomic mass, if it is a molecule we say molecular mass. Okay, so here 1 gram divided by the atomic mass. So the atomic mass of magnesium is how much actually? We know that that is 24 gram per mole. Correct, gram mole raised to -1. So what will be the answer? If you divide 1 divided by 24, how much it will become? So this will come around 0.0416 mole. So first quantity we have converted into mole. Now the next one, similarly, tell me, how can you convert this into mole? The given mass, that is 0.56 gram, correct, divided by the molecular mass, since it is molecule. So we can say molecular mass 16 into 2, 32 gram per mole, mole raised to -1, correct. So if you divide this, you will get a value 0.0175 mole. Now, this is what given to you for this reaction to happen. That is 0.0416 mole of magnesium and 0.0175 mole of oxygen. Now, as per stoichiometry, tell me how much how much mole of magnesium is reacting with how much mole of oxygen to produce how much mole of magnesium oxide. I know that as per stoichiometry 2 mole, correct, 2 mole magnesium needs tell me 1 mole oxygen O2 to produce, I can say, to produce what? 2 mole magnesium oxide, correct. Now, what they are asking in the question, which reactant is left in excess and how much? So they are telling that when you are given magnesium of this much quantity, that is 0.0416, and O2 of the quantity 0.175, one of the reactant will be left in excess. That means there is a limiting reagent in this case. Whenever there is two reactant and the given quantity is given for two reactants, always there is a possibility of limiting reagent. Okay, so we will check how to do this limiting reagent here. So I have a shortcut for you to find out the limiting reagent. To find out the limiting reagent, what you need to do is take the first case, that is magnesium. Okay, take its number of moles. What is the number of moles? 0.0416. Okay, divide by the stoichiometric value, that is 0.0416 divided by the stoichiometric coefficient is what actually for magnesium it is 2. So tell me how much it will come. 0.0208. Correct. Now similarly do it for oxygen. Okay, so for oxygen it will come like, okay, what is the number of moles? 0.175. So what you need to do, take this value 0.175 and divide by the stoichiometric coefficient, that is 1. So we know that the value here is 0. Okay, there is a 0 missing here, so you should add that. So 0 point here also 0.175. So I can say 0.0175. Correct. Now compare these two values. Compare this. Which one is the lower value? So I could understand that 0.0175 is the lower value. In that case, this will be my limiting reagent. Understood? So if this is the limiting reagent, now how we can proceed? I can say that oxygen will be controlling the entire reaction. Correct. So who will be left in excess? Now I got the first part of that answer. So which reactant is left in excess? So we know that limiting reagent is that species which is completely consumed, used up in a reaction. So if oxygen is completely consumed, who will be left in excess? Magnesium. Correct. So we will write here. Okay, so we will write here oxygen is the limiting reagent. Oxygen is the limiting reagent. So magnesium will be left excess. Will be left excess. Correct? Okay. Now, if you see here, they have also asked which reactant is left in excess and how much is also they are asking. So we will calculate that. We know that if oxygen is the limiting reagent, everything will proceed according to oxygen. Correct. So we can say that as per, we will first start with stoichiometry of oxygen. We know that 1 mole. So we say now 1 mole oxygen, okay, produces 1 mole oxygen produces what it will produce? 2 mole magnesium oxide. Correct. Now tell me the other way. 1 mole O2 needs tell me 2 mole magnesium. Correct. This is for 1 mole. This information we have written with respect to stoichiometry. Now, how much mole of oxygen you have? You have 0.0175. Correct. So now we will speak with respect to that. So next we will write 0.0175 mole O2 produces. We will go through all the part so that you will, if they ask how much amount of magnesium oxide produced, then also you can do this. 0.0175 mole of O2 produces. So we know that 1 mole O2 is producing 2 mole. So 0.0175 mole O2 means what? You need to multiply 1 with 0.0175. So if you are multiplying here, multiply on the right hand side also. So you can multiply 2 into 0.0175 mole magnesium oxide will be produced. So what is that value? So if you calculate that value, it will be coming around. So we will just calculate that. Okay. So that value will be approximately, I can say 0.0175 multiplied by 2. So this will come around 0.035. So I can say 0.035 mole magnesium oxide will be produced at the end of the reaction. But this is not the question. They are asking how much magnesium is left excess. Okay. So we will calculate how much magnesium is used in the reaction. So we know that 0.0175 mole of O2, correct, is used. So that means 1 mole O2 needs 2 mole magnesium. Now tell me 0.0175 mole O2 needs how much? 1 mole is requiring that. So if you need 0.0175 mole O2 means multiply by this number on LHS and RHS. So this will become 2 into 0.0175. So again you will get the same answer, that is 0.035 mole magnesium is used. Correct? Is used. Now tell me how much magnesium will be left excess. So we can say magnesium which is left excess is equal to initial quantity. What was the initial quantity you have? So what is given to you? That is the initial quantity. Okay, the initial quantity given to you is what actually? So here magnesium which is left excess is equal to initial quantity minus final quantity. So the initial quantity, if you see here, we have already calculated, that is 0.0416, correct? So if you see here, that is we have done 0.0416 mole. That was the given initial quantity. So we will take that as the initial quantity and 0.0416 minus, if you want to find excess, we need to subtract it with the amount that is used in the reaction. How much is used? 0.035 is used in the reaction. So tell me what is left behind. If you do this subtraction, that is 0.0416 minus 0.035. So if you calculate it, it will come around 0.0066 mole. So I got the answer, that is magnesium which is left in excess, that is not used in the reaction, is 0.066. What about oxygen? We know that oxygen is completely used in the reaction, correct, since it is the limiting reagent. Now suppose in exam they have given the option not in mole but in terms of mass. Then how will you convert this in mass? I can say magnesium in grams which is left excess is equal to, how will you find out that? So we know that number of moles is equal to weight in gram by atomic mass, correct? So tell me what is weight in gram then? So we can say magnesium in gram is equal to number of moles multiplied by atomic mass. So number of moles we know 0.0066 into atomic mass of magnesium, that is 24. So what will be my answer if you multiply this with 24? I will get the answer as 0.1584 gram. So very simple. My conclusion is, now tell me, we have taken 0.0416 mole magnesium is taken, and out in that how much is used in the reaction? 0.035 mole. We can see here So how much is used in the reaction? 0.035 mole of magnesium is used, and the left behind was 0.066 mole. Okay, and if you convert this into gram, the answer will become 0.1584 gram. Even sometimes they can ask you how many molecules of magnesium is left behind. In that case, you need to convert this mole to number of molecules. We know that 1 mole is equal to Avogadro number of molecules. So 0.006, 0.0066 mole means 0.066 into Avogadro number. So you will get the number of molecules. So I hope you understood the lecture, this question. So this is a lengthy question. Sometimes you could expect questions like this for your NEET exam. If you practice it, this becomes much easier. Okay, so for more lectures, please contact Brainiacs Classes, and if you have liked the explanation, please subscribe our channel. Thank you.